Unlike most of my videos, this one is only going to look at internal rate of return. And when I say most of my videos, we're just looking at one tool. This is bizarre. But this tool is both the most popular among practitioners and the most problem-riddled of all of the tools. And so we're going to be looking in this instance at internal rate of return. And so first off, what in the world is it? This is the most important alternative to net present value, NPV. It's often used in practice and is intuitively appealing. It just makes a lot of sense, and wow, I know exactly what this is measuring, and sometimes we're just a little off. And therefore I'm going to apply this a little inappropriately. It is based entirely on the estimated cash flows and is independent of interest rates found anywhere else, including the weighted average cost of capital. The decision rule, on the other hand, uses the weighted average cost of capital, and therefore it uses the time value of money, it uses the risk. We can embed all of those things in it, so it's doing it after the fact, though. We're finding the internal rate of return. Let me get to the actual definition, and then I'll give you the believed definition and say, well, that's not quite accurate. So here's the actual definition. We're going to take all of the present value of all of those cash flows, we're going to add them all together, and as you know, that equals the net present value. But then we're going to say, now let's adjust the return, that weighted average cost of capital. We're going to adjust that until we find the interest rate, which I'm going to call K, that will yield a 0 net present value. What most people then say is, therefore, this is the return on that particular investment. I don't know that I'd go quite that far. I'll show you why in just a second. The decision rule, therefore, is accept this new project, adopt it, if the IRR, the internal rate of return, is greater than the weighted average cost of capital after adjusting for risk. What most people interpret this as is the internal rate of return represents the effective interest earned on the investment. That one I have a little bit of trouble with for a reason I'm about ready to share with you. And the biggest, well, let me actually share it now, which is that would be nice if you could give me one number, but in some instances you can give me more than one right number. And that could be a problem. At this point, let me tell you how we calculate IRR. To compute the IRR for a project, what we would end up doing is essentially, and here's the problem, we can't do this algebraically. You'd have to use a financial calculator or a computer. If you don't have a financial calculator, then it becomes an issue of trial and error. Even with a financial calculator, if you don't have an IRR key, it still is first off, you don't have a financial calculator, but second off, then it's also trial and error. So with the calculator, what you do is enter the cash flows as you would for net present value, press the IRR button, and then compute it. And if we get an IRR of 16.13%, as long as that's greater than my weighted average cost of capital, say of 12%, these are all examples, then what do we do? Do we accept or reject the project? The answer is we accept the project because it's actually earning, I'm doing my quotation marks with my fingers, which you can't see, earning more than my weighted average cost of capital. So let me give you an example. First, yeah, this is the same example. You were probably expecting it anyway. I have my project gamma and my project psi. I have my outlays and my incoming cash flows. And so when I look at them, I create my little timeline. There's my negative 1500 and 450, 460, 470, 480, 490 incoming cash flow. What discount rate do I use? The answer is I don't use any. What I'm trying to do is figure out what discount rate will give me exactly a net present value of 0. So that's what I'm solving for, is the discount rate. And calculators and computers crank through this by essentially guessing at it and going through an algorithm until it gets to the right answer. It will go so fast, though, that you'll think that it has something that it can do that with really, really, really quickly, and it can't really. So in this instance, the gamma, project gamma, gives me 16.82% return on my investment. Now, compared to the earlier story where we had a discount rate, a weighted average cost of capital, a WACC, of 9%, this is a good internal rate of return. I'm getting, again, my fingers are doing the quotation mark, a 16.82% return on my investment, and I'm only having to pay 9%. Now the 9% part I didn't have my fingers going return on, because no, that's actually what I have to pay. Now my project Psi, if I do the same numbers there, I do negative 3,000, 755, 855, 955, and all those positive incoming cash flows. Again, I'm not putting any discount rate here. It's going to find the discount rate that makes the net present value 0, and it finds 16.37%. Again, 16.37% is higher than the 9%, therefore we would accept this project as well. To begin with, I want to point out that I got rid of all my extra lines here that were between weighted average cost of capital and NPV, and then between NPV and payback period, because I really didn't need them anyway. Let me hit now my IRR. The IRR for this particular company, just to show you that they're the same as on the PowerPoint slides, is equal to IRR, yeah, it's that easy, and then we include all of the cash flows, including times 0 cash flow. And I'm going to close my parenthesis, enter, and go up, grab that one and pull it over 1, and voila, we end up with the right numbers there, 1682 and 1637. But IRR has certain problems because that's just too intuitive. Part of the problem is that this intuition just is not completely founded in reality. But the first one is that we assume that any money coming back in is going to be reinvested at the same rate of either 1687 or 1682, whatever that was, and 1637 or 1632, whatever that was. So either way, I'm assuming that I'm going to be reinvesting at substantially above the weighted average cost of capital in these cases, which probably isn't going to happen. The other problem, in my opinion, is far worse in that there isn't one right answer necessarily. So as it turns out, we're going to find out later that in these instances there is only one right answer, and because of that we can probably draw some stronger conclusions from this, but we still have the same problem with that first one, in that we're assuming that we reinvest at the IRR rate, and the other problem, well, we'll get to in a second. But this second one, with more than one possible right answer, makes this feel less like math and more like English. And so let me explain to you why we end up with 2 or more right answers by giving you an example. This is an example of a set of cash flows that have 2 right answers. Let's assume you have a project that will return a positive 4,000 in year 0. So let's assume that I'm salvaging an old machine and then there's some financing in place and I don't have to actually pay for anything the first year, and so I get a positive 4,000 in my first year. The second year, which is really the first year, year one, so in my at the end of my first year, what I get out is a negative $25,000. Ouch. That's when I actually had to pay for the machine, perhaps. And then in the final year of the project, I get a positive 25,000. So I've actually, those two have kind of balanced one another out, and I've really made 4,000 up front, and so I should be okay, right? What kind of a return did I make on my investment? That's what people think IRR is calculating, and so let's find out what kind of a return did I get on my investment. I'm going to go back to the definition of IRR. Remember, it's defined as the net present value and setting that equal to 0. So I'm going to set this up to take the present value of all of those cash flows. And I'm not going to set my discount rate. I'm going to solve for it. So here we go. I have my $4,000, which is already in time 0, so I don't have to discount that at all. Then I have a negative $25,000, which I'm discounting at 1 plus k, which is what I'm solving for. And then I'm going to add to that 25,000 that I'm discounting 2 years, which is why I'm taking it to the second power, 1 plus k to the second power. And then I'm going to set that whole sum equal to 0. That's exactly the way I did this before when I did my net present value by hand in Excel. Now, because I'm going to set this equal to 0, and I want to make my life a little easier, the very first thing I'm going to do is divide both sides, both the equation and the 0, by 1,000. So I'm going to divide both sides by 1,000, which gives me 4 minus 25 over 1 plus k plus 25 over 1 plus k squared equals 0, because 0 divided by 1,000 is still 0. And now I'm going to do one other thing just so that I don't have the fractions to deal with. I'm going to multiply both sides by 1 plus k squared. Now, of course, on the right side, the equals 0 side, 1 plus k squared times 0 is still 0. But on the other side, I'm going to get 4 times 1 plus k squared minus 25 times 1 plus k, because the 1 plus k squared times that component is going to cancel one of the 1 plus k squareds, because the numerator has 1 plus k times 1 plus k, and so one of the 1 plus k's cancels out, and I get just the 25 times 1 plus k. I'm hoping that makes sense. Plus 25, because the 1 plus k squared divided by 1 plus k squared is just 1, so yeah. Okay, if you didn't get that, let me try that one more time. Multiply both sides by 1 plus k squared yields just that. Whew. And by the way, in the first case, I did the 1 plus k squared and expanded it. So we get the 4 plus 8k plus 4k squared minus 25 minus 25k plus 25. Wait, the negative 25 plus 25 leaves me with nothing in that instance. So in the ones place, without any k's, I just have the 4 times 1, or the 4. Then in the k's, I have, let's see, the 4 times 2k, that's 8k, minus 25k, which gives me minus 17k. And in the k squareds, I just have the positive 4 times k squared. So I get 4 minus 17k plus 4k squared equals 0. Now, hopefully, most of you will recognize that what we have here is really a parabola. So if you remember your high school algebra, and I do because I'm working with one of my children who's in high school and taking algebra, this is a parabola. And what we're doing when we set it equal to 0 is we're solving for where this crosses the x-axis. So if we replace this with a regular parabola, it would look like this. It would say 4x squared minus 17x plus 4. I'm just doing this backwards because I'm dyslexic and I can do that very easily. And at this point we're going to find out where that crosses the x-axis. It could cross in no place, or it could cross in two places. Those are the two options. Or it could touch in just one place. I guess there are three options. However, in this instance, the easiest way of finding the solution is by factoring. So I'm going to factor this polynomial, and I end up with 4k minus 1 times k minus 4. And if you sit and work through this enough, you'll notice that the 4k times k is 4k squared. 4k times 4 is negative 16k, because it's a negative 4. Then as we do the negative 1 times k, that's a negative k, and when we add those two together we get the 17k. Then the minus 1 times the minus 4 is the positive 4. Oh yeah, that does equal this stuff up above. So therefore, either 4k minus 1 equals 0 or k minus 4 equals 0. I cross in two places. That means that k, that discount rate, is either 25%, that's the 4k equals 1, because in that case k is equal to 0.25, which is 25%, or k equals 400%, which is where the k equals 4. Let me show you how to get both. Believe it or not, we can get both. How to get both of these IRRs using Excel. It may take a little bit of guessing, and if one of them is too far away from 0, it just won't even look there, by the way, just so you know. But let me show you how to get it to find it if they're not too far away from reality. Even though you can't see this, I've actually changed from sheet 1 over to a new sheet 3 in this instance, and I want to set up this last example in this space so we get time and cash flow. So I'm going to do time 0, 1, and 2. Now the cash flows that we talked about were 4,000 the first year, or well, at time 0, excuse me. Then there was a negative 25,000, and then there was a positive 25,000. I'm going to go down here and say, therefore, what is IRR? And I'm going to say equal IRR, open parenthesis, highlight my cash flows. Now before I hit enter this time, I'm going to point out that the argument actually has a comma and a square bracket that says guess. Now anything in a square bracket is optional, and if you don't enter a guess, it has a default. In this case, I think the default's 0. So I'm going to just, in this instance, put my closing parenthesis on and hit enter, and notice it tells me 25%. And extra decimal points are pointing out, by the way, that that's not rounded, it's really 25% even. Now I'm going to say equal IRR, and this time I'm going to use that guess. So I'm going to highlight those, put a comma there, and say this time try something out there about 200%. Notice I'm not even halfway there. I'm going to say enter, and it gives me the 400%. It's giving me both roots, and by the way, if you tried 300%, because I've tried this before, it will go give me something real. So 200 is about out there as far as you can go, and it still goes okay. And we're close enough to where getting to the root is going to get it out there further. So hopefully that makes sense. And if not, let me show you this graphically. If that didn't actually work for you, let me try graphing it. If I graph this parabola, and remember, because it is an x squared and the coefficient to the x squared portion, or in this case the k squared portion, is positive, then it looks like this Cheerio bowl, okay, or a smiley face. Which, if you put the two together, your Cheerio bowl is right side up holding your Cheerios, and therefore you have a smiley face. And if you turn it upside down, well, then your Cheerios fall out of your Cheerio bowl and you have a frowny face. I'm hoping you can see that. So if you have a negative coefficient, it's downward sloping, and it's concave because you're in a cave. And if it's positive, then it's convex and a smiley face and kind of this way, okay? And what we're doing is we're trying to find out where this is crossing the 0 on the y-axis. Notice that's where we hit 0. Because our k, in this case, or our x-axis, is the discount rate, and our y is the net present value in thousands of dollars. Note that if we have 0 discount rate, then we have the 25 minus 25 plus 4,000 is 4,000. That's why it hits 4 right there. Then it crosses at 0.25, where k is 25%, and after that the net present value of this function goes negative, at which point we would not adopt the project until our discount rate gets up to 400% or beyond, at which point our net present value becomes positive all over again, and it makes sense all over again to invest in the project. The problem with most of these IRRs is we don't know by just looking at them whether this is an area where we are positive or negative NPV'd. And because of that, it's really hard to interpret this if we have more than one IRR, which makes this a real mess. And despite the fact that this is a smiley face, this can really frustrate you and make you into a frowny face, okay, really quickly. So let's see how good a job IRR would do as a criteria for deciding whether we should invest in this thing or not. Number one, does the IRR rule account for the time value of money? Well, remember, it's telling us if the K in this case, or the IRR, is higher than our discount rate, then we should invest. And we are taking into account the time value of money specifically because we include that net present value calculation in figuring out what the IRR is. So does it take into account the time value of money? Yes, it does. Does the IRR rule account for the risk of the cash flows? Well, because we can adjust the weighted average cost of capital, the hurdle rate, for risk, the answer to that one is also yes. Does the IRR rule provide an indication about the increase in value? Not directly. It might tell me, and I'm putting my quotation marks that you can't see with my fingers, it does tell me the return, and therefore it gives me some indication as to whether my value's going up or down, but it really doesn't tell me whether I'm making the best choice for my shareholders and increasing the value of my firm the best I possibly could. So that one is weak there at best. So should we consider IRR rule for our primary decision criteria? Let's see, we have a yes, and a it could be better. And since NPV had a yes, yes, and a yes, net present value is probably a stronger decision criteria than IRR. So the advantages of IRR is that knowing a return is intuitively appealing. So I'm saying, well, it returns such and such. It's a simple way to communicate the value of a project to someone who doesn't know all the estimation details. I'm saying, oh, that would return 25%. And you're going, wow, that's really impressive. I can't get an investment that makes me 25%. If the IRR is high enough, You may not need to estimate a required return because you can say, I know my weighted average cost of capital is not 25%, even if I adjust for some risk, which this one doesn't have any extra. And so you can actually do that without doing a weighted average cost of capital estimation, which may be critiqued by those people who are looking at it and going, well, I don't know if I agree with that weighted average cost of capital adjustment or estimate or whatever. So if I'm comparing net present value and IRR, first off, net present value and IRR generally give the same answer, which means if one of them says this is positive NPV, the IRR is, I've never seen this where it doesn't happen, but the IRR will come out to be greater than the weighted average cost of capital. So in those instances, and I've never seen this not work, if NPV is positive, IRR will be greater than weighted average cost of capital, so the thumbs up on one will be the thumbs up on the other. There are some exceptions to giving the same answer, though. The first one is if the cash flows are non-conventional, which I'm going to get to in just a sec. That means the cash flow sign changes more than once. I'm going to give you a hint. And if it changes more than once, then we may have more than one right answer, which can be really nasty. The second problem that we have is if the projects are mutually exclusive, in other words, I can't do both. I have a project A and a project B. Project A uses a specific parcel of land, and project B does as well, and I can't do both of them at the same time, so I've got to choose one or the other. Then it doesn't matter as much that they both have positive net present value. The IRRs may be both greater than weighted average cost of capital, but then ranking them becomes critical, and I could rank them completely differently, which was true in our example as well, because they ranked completely differently. The initial investments in both may be substantially different. In our example, they were twice as much. The project Psi is twice as high an initial investment as project Gamma. And so project Gamma, in many ways, doesn't need to return quite as much before its IRR is higher than project Psi. The timing of the cash flows may be substantially different, and in that instance the risk may be a little bit different because I may be getting more of my return later in one and earlier in the other. And if that's true, the earlier one may have less risk than the later one. But again, we should be able to adjust for that in the weighted average cost of capital that we use, both as a hurdle rate and as a discount rate in the case of net present value. But because we do have these exceptions, which one should I use? When the cash flows, and before I get into that, let me hit the when is there a non-conventional cash flow. When the cash flows change sign more than once, there may be more than one IRR. When you solve for IRR, you're solving for the root of an equation. When you cross the x-axis more than once, there will be more than one return that solves that equation. If you have more than one IRR, which one do you use to make your decision? When does that happen? Well, multiple IRRs are only possible with non-normal, non-conventional cash flow streams. The conventional cash flow stream looks like this. Project costs are all up front, meaning the outflows are all together, one period after another or just one period only. But they're all up front. All the negatives are negative, 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 negative. You could have a whole bunch of negatives in a row and it's still a conventional cash flow. But they're all the outflows are all together and all up front. They're followed by a series of positive cash flows and their inflows all the way through the rest of the cash flow stream. There's only one change of sign from negative to positive. If that's true, then you have a conventional cash flow stream. A non-normal, non-conventional cash flow stream has two or more changes of signs. So you could have a negative, a positive, a negative, a negative, positive, 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 positive. Or you could have any set of different changes. The most common in real life is where the upfront costs are negative, therefore there's a net outflow at times 0. Then there's a string of positive inflows, and then in the last time period you have to clean things up and clear things out, and therefore that last cash flow tends to be net negative. So we have a negative, a bunch of positives, and then a negative at the end. That's a non-conventional, non-normal cash flow stream and runs the risk of yielding more than one right IRR, which can ruin your whole day. If there are conflicts in ranking between net present value and IRR, NPV directly measures the increase in value to the firm and therefore should be used. Whenever there is a conflict between net present value and another decision rule, you should always use net present value. IRR is just unreliable whenever there is a non-conventional cash flow stream. Therefore, especially in those instances, use net present value. Also, when there's mutually exclusive projects that we're taking a look at, we will look more closely at the net present value than we will at the internal rate of return.